In many organizations, FTP has been implemented in a piecemeal fashion, and we've learned some lessons from past mistakes. Today, I'd like to describe to you a little bit about what we've learned and how you can use this to be able to answer questions, because more and more CIOs and CISOs are being asked, demonstrate that we have complete security. And there's some things we've learned about what you need to do to be able to answer that and, frankly, to sleep at night. So what we're going to do today is we're going to talk a little bit about introduction and history. We'll explain what FTP is, how we got to where we are, and then we'll explain how the security works. We'll give you some examples, and then we'll wrap it up with a summary and a call to action. First, FTP, or File Transfer Protocol. I've got two meanings or definitions. They're related. The first one is it's a set of rules or a protocol for standardized transfer of files between computers. So if I've got a Windows computer or a mainframe or a Unix computer, and I want to send a file to your computer, which could be Windows or Unix or mainframe or whatever, or I want to get a file and bring it back down, this is the rules that both computers have to follow for this to work, all over the internet, of course. Now, the second definition of FTP is the software that follows these rules to make that transfer take place. Little history to show how we got here. Before we had FTP, a long time ago, if you wanted to transfer files, a common way of doing this was you would print the file, you'd postal mail the printout to the other location, and then the other location would have people key enter the data, and this was, of course, inefficient and slow and error prone. So we got smarter. Someone then said, hey, let's not print this stuff and retype it. We'll just copy it to tape, and then we'll send the tape over. And in some cases, the tape got stolen off the delivery truck, and people got into a great big argument and wasted a lot of time and energy saying, who's responsible? And Congress finally decided pretty much that if the sender encrypted the data on the tape, then the sender's not responsible. But if you didn't encrypt the tape and it got stolen off the truck, then maybe you were responsible for the loss of sensitive data. And so things went back and forth on that. It was still considered insecure and still slower than we really wanted. So the next step in our history, someone invented TCP/IP and the internet, and on top of TCP/IP, they invented the FTP protocol. It works on any type of computer you could imagine. It works cross-platform. It works across oceans, across cultures. Now, some versions of the FTP software programs, there are different versions from different vendors. Different people wrote their own. As long as they basically follow the rules, it was considered okay. Some of them support encryption. Some of them support some types of encryption, but not others. And the regulations for encryption are changing, and the technology is changing. But once we had FTP, this was a big improvement over mailing printouts or delivering tapes. It was considered fast and easy once you had it set up. Now, in some organizations, we found out the hard way, each user could implement whatever version of FTP software he wanted. And some of them would have a version that somebody wrote from some company, and someone would have another version that someone else wrote from another company. Some of them were free downloads over the internet. Some of them were pay for, and the quality varied. And sometimes they worked together, sometimes they didn't. They all had to follow the same set of rules, but we didn't have uniform control. And users could also choose, it was the user's choice, what data to encrypt. And if you've ever been close to a deadline and you finally had your product ready to deliver to the other party, almost the last thing that crosses your mind is going to be, gee, I wonder if I need to encrypt this and what's the best way to encrypt it. So in a lot of cases, what we saw was people would send stuff without encrypting it because no one told them to, or they were in a hurry, or the question never crossed their mind. So this whole business of having FTP was a big improvement, but it was considered in some cases, because of the lack of centralized control over encryption, insecure. It was disruptive, because if you had two people each with their own version of the FTP program trying to share files with each other, if it didn't work because of minor differences in the way they followed the rules, then you'd end up wasting a lot of time. So if the different versions didn't act very well together, you'd end up with a lot of wasted time and energy. So here are some things we learned from this history, some lessons learned that I hope are going to make it easier for all of us to make things better and more secure, and also easier to demonstrate that they're secure. So some things we learned. First, if two versions of the FTP software don't work together smoothly, users are going to waste time and they're going to be frustrated. Second, different computers can use different ways of encoding bytes. A byte is like one character of data. So there are two different coding formats, ASCII and EBCDIC. And if you're dealing with organizations that use a different alphabet, or things like Japanese characters or Chinese characters, sometimes what you would need to use is double byte character sets. And the details of that we're not going to go into here, but if you're dealing with different alphabets or different languages, in many cases you'd have to use double byte character sets, although some versions of FTP didn't. And of course, there are two different ways of organizing the bits in a byte. You can think of big endian and little endian as going left to right or right to left. And again, we're not going to get into the details. The important point is, even if you're following the rules, there are lots of ways that different implementations of the FTP program can not work together. Some more lessons learned. Users are not going to activate encryption in every case where it's needed or required, because if it's 3 o'clock in the morning and I'm just about to make my deadline, I'm not going to worry about what the compliance department might tell me about PII or HIPAA or securing my user ID and password or whatever. So if you want to have really good security and know it and be able to demonstrate it, you need to make the encryption automatic anytime that it's needed, so that no user will be able to send sensitive data off your computer without you having a way of saying, if it needs to be encrypted, I'm going to make it encrypted automatically. I can't rely on people who are just close to deadlines at 3 in the morning to remember about what the encryption rules are. Some more lessons learned. Some standardization for FTP is going to make things more efficient, more secure, and more compliant. And as much as anyone I know, I don't like to have people tell me what to do or tell me I can't use my version of something, I have to use the organization's version. But if you don't have some standardization, you're going to run into the problems that we're talking about here, the failure of different versions to talk to each other, all the differences in ways of encoding data, and failure to encrypt if people aren't required to encrypt automatically when it's needed. It's hard to manage FTP, and you need to manage it. You can't let this be done by each individual in his own way of doing things. You can't manage FTP security, and you can't demonstrate FTP security if you don't know what files are being transferred to and from, and where they're being transferred to and from. So if you have a collection of Windows and Unix computers, maybe you have a mainframe as part of the same network, and there's sensitive data on there, if you don't have a way of knowing what's being transferred to and from your computers, it's really hard for you to say, oh yes, we've got good security and nothing's here that shouldn't be, and nothing sensitive is being disclosed that shouldn't be disclosed, and everything that needs to be encrypted is of course being encrypted. So with that set of lessons learned, let's talk a little bit about FTP basics just to get everybody up to the same level. If you want to download a file, so if you're on one computer and you want to download a file over the internet from some other computer, with FTP what you do is you issue a GET command. You start the FTP program on your computer, and when the FTP program starts up, you issue it the GET command to tell it to go get the file from that other computer. If you want to upload a file, if you want to send a file to another computer over the internet, once your FTP program starts running, you issue the PUT command. Now, you've got two computers involved. One of them sending, one is the receiving, but one of them will always be the client, and the other will be the server. And the way you know which is which, the client is the computer that speaks first in the conversation. So if you want to get or put a file from or to another computer, on your computer, you'll start the FTP client program, and you're going to tell it you want to shake hands with whatever the other computer is, the FTP server program on that other computer. Very likely you will then have to prove who you are to the FTP server program on the other computer. You're on the client program, the other computer is running the server program, and then you're going to issue GET and PUT commands to request the file transfers. So we've got three basic issues for FTP security here. First, how do you prove your identity to the FTP server? Do you send a user ID and password? And if you do, maybe you need to encrypt the user ID and password. Do you need to encrypt the data while it's going over the network? Is our second issue. And the third one is, who's allowed to upload and download what files? Now, this is questions for you to be thinking about from your client program, but the server program, the computer on the other end, is going to have its own point of view, but it's going to have the same three issues: proving identity, do we need to encrypt, and who's allowed to upload and download what files. So you can see the same three questions, the same three issues from the client point of view, but you can also see it from the server computer's point of view. Let's illustrate with an example. Suppose someone, maybe it's you, you're sitting at a Windows computer and you want to send a file to some other computer, a Unix computer. You log on to your Windows computer and you start the FTP program. It's the client FTP. Now, you're sitting at your Windows computer, you started the FTP client program because it's going, you know it's the client because it's the one that's going to talk first, and you tell it to go reach out over the internet and find the other computer and find the FTP server program on that other, in our example, Unix computer. Now, we hope that the Unix computer has the FTP server program already running. It's just sitting there waiting for someone to ask it to serve. That's why we call it the server version. So the FTP client program, the one that you're running on your Windows computer, shakes hands with the FTP server program on that other Unix computer. And the Unix FTP program asks the FTP program on your Windows computer to log on to prove who you are. Now, your Windows program might ask you to enter a user ID and password or some other way of proving who you are. You type in the user ID and password, your FTP program sends the user ID and password to the FTP server program on the Unix computer, and that other computer uses whatever means it uses to verify your identity. So the user ID and password in this case gets checked out by the server computer. So it's not the user ID and password that you use to log on to your Windows computer, it's the one that the server computer expects you to enter to prove who you are to the server program. So then you type in get or put commands to upload and download files. And if you walk through this example, you can say from each point of view, from the client computer's point of view, and also from the server computer's point of view, 3 issues. How do we prove the identity of the other computer or the other person at the other computer? How do we encrypt data? How do we know what data we need to encrypt? And who is allowed to upload and download what files? Now, you could repeat this example with lots of different computers, uploads, downloads, and also automated execution we'll talk about in a moment. But I think you've got the basics of the architecture of how this all flows. We'll wrap this up now with a summary and a call to action. When you implement FTP in your organization, you can't allow it to be piecemeal, with each user deciding what version of FTP to put on his computer and how to send files back and forth and whether to encrypt them. So if you're going to implement this organization-wide, enterprise-wide, and you need to do this, here's some questions you need to address. How do you know what files are transferred to and from where? How do you know that you don't have some rogue employee or contractor or even a customer or user who is somehow FTPing files to and from your computer and you don't even know what's happening? If you allow that, it's hard for you to say, oh, we've got our security completely under control. Second question, where is encryption needed and how is it enforced? It's one thing to know, oh, this has credit card information or a password or PII information or stuff that's subject to the new European encryption or data protection regulations or whatever. It's one thing to know what encryption is needed, but how do you make sure that the encryption happens? And along with that, there's the question of the technology. Without getting into the mathematics, there are different mathematical algorithms that are approved, and as time goes by, the weaker ones fall out of favor and you're then required to use newer, more secure algorithms. How do you make sure that the correct algorithms are being used? If you want an example, at one time there was an algorithm called DES, D-E-S, Data Encryption Standard. At one time it was the standard, and then after a while people learned that they could crack it given enough time, and so the government and mathematicians came out with a newer, more rigorous standard called AES, Advanced Encryption Standard, and now we say the DES encryption is deprecated. It's no longer valid or supported. You need to be using the AES encryption. If you have someone in your organization who is encrypting things with FTP or otherwise, and they're still using DES encryption because no one told them that DES encryption is no longer acceptable, how do you know you've got good security? It's hard to do if you don't know where the encryption is in your organization and how it's being done. And the last issue here, well, not the last, we've got some more, but the third one on this slide, sometimes what you want to do is encrypt a file once, and maybe your computer sends it to another computer, which forwards it to another, which forwards it to another. And if you want to have better security and maybe more efficiency, what you want to do is set it up so the file gets encrypted once, and it only gets decrypted when it arrives at its destination. You don't want the intermediate computers decrypting the file and then re-encrypting it, perhaps with a different algorithm or different keys. So as you implement FTP, you need to consider these issues. You need to make sure that all the versions of FTP in your enterprise work together as they're needed. And you also need to be able to handle automated batch transfers. For example, you might have something where you say, every Thursday at 9 o'clock, I don't want to be there. I've got other things to do Thursdays at 9 o'clock. So automatically, just without me doing anything, send this file to Washington every Thursday at 9 o'clock. You need to have a way to ensure that all the laws and regulations that apply are identified and enforced. And you'll discover that we've got some new ones coming at us now. The GDPR from the European Union, which may apply to you even if you think it doesn't. New York State has some new financial organization requirements, and various governments have other things coming along. So when the regulations or the technology changes, how do you identify all the places you need to upgrade? Upgrade if you don't know all the places where you encrypt. This is why you need centralized authority, centralized control of FTP. If you want to prevent data leakage, what stops a user? Suppose you've got some user who has read access to some sensitive file, and you want him to have that because he's authorized, he needs it to do his job, it's been evaluated and approved. But what stops him from FTPing that sensitive data from your computer where you have all the security, maybe to his home computer, maybe to his laptop, maybe to a friend of his who's interested in whatever data you've got? How do you prevent that kind of data leakage? You have to know what FTP processes are going on. You need to make sure that the FTP in your implementation works cross-platform, cross-culturally, that addresses all of these issues. You also need to identify how FTP identifies or verifies the identity of each user. You can sometimes do this with passwords, but of course if you do, you'll need to encrypt the password. The other techniques are digital certificates, Kerberos, and sometimes you can even have anonymous FTP, but you'd want to be careful about when you allow that to happen in your shop. You also want to ask what user IDs apply to the FTP programs themselves. So when you log onto your computer, you enter a user ID and password to prove who you are. But very often an FTP server program will be running with its own user ID and sometimes its own password. And so in some organizations, they take the user ID for the FTP server program and they give it privileges so it has total access to every file on the system. And that's probably inviting risk you don't want to have in your system. So last point here, what degree of standards and enforcement is called for? We've got some issues to think about, but once you settle these and deal with them, your life is going to be much easier and you're going to have much better security, and your users are going to have less frustration when they find FTP doesn't work. So to wrap this all up, if your job includes data loss prevention, if you're a CIO, you're responsible for DLP. If you're a CISO, you're responsible for DLP. If you want to know that your organization has good security over FTP, you have to have a way of knowing what FTP is happening on your system, that no FTP can occur without your approval, and that no FTP occurs on your system without someone determining what security it needs and making sure that that security is provided. So I hope we've given you some good things to think about. I think if you address these issues, you'll find your life is easier, you'll have better security, your users will be less frustrated, and will be much easier to demonstrate to auditors and to others the quality of the security in your IT enterprise. Here are some sources of more information if you just want to get some more stuff about standards or ways to think about FTP and overall IT security. And with that, I'll say thank you very much for your kind attention, and I'll turn you back to Colin now. Colin, take it away. Thanks.